Hi, hello everyone, welcome back to the channel. So today we'll be solving a new problem, that is Coco eating bananas. Okay, so in this problem, what we have given a piles of bananas, right? And also one integer, that is h, that represents the hours. Okay, so what we have to do in this question, so we have given these piles of bananas, so we have to eat all the bananas. Actually, not we, this Coco will eat the bananas. So we have to eat all the bananas. Okay, under this h, that means under this 8 hours. Okay, how we can eat it? So we have to give the value of k. So what this k is? K is the speed at which the Coco will eat the banana. Okay, so but the constraint is that we have to return the minimum integer k such that he can eat all the bananas within h hours. Okay, so this is the problem statement. Suppose if we start with the value 1, okay, then he will eat one banana, then these two bananas will be left. Okay, after that, he will again eat and one, and after that, it will be 0. So that way, it will take 3 hours, right? For this one only. So this is how we will be calculating that. Okay, so suppose we are taking this k is equals to 1, then we will continue eating until we get the value as 0. Okay. So that way this will be 3, then plus we'll move to the other banana. This 6, then the same, it will take 6 hours. Okay. But the value would be greater than h. But we don't want that. Okay. So this is not a valid condition. So we'll move to the next element. Okay. Then we will take k is equals to 2. Then we'll check again. Okay. If this is valid or not. If not, we will move to 3 and so on. Okay. We will check with 3. Then we will move to 4. Okay. Now this 3 is less than 4. Okay, so we have given another condition in the question, if you have read that. So if the pile has less than k bananas, she will eat all of them instead of other ones. Okay, so it means that suppose the value of k is 4 now, then it will eat this banana. Okay, so our value would be 1 right now. Okay, plus, but we have only three values, we have one value left, but we can't eat anything else. Okay, she can't eat anything else because if she's eating one pile, so she has to take only one pile at a time. Okay, she can't eat the another pile until that ours is gone. Okay, so this is the problem statement, that she will not eat any more bananas during this hour. Okay, we will do the dry run for k is equals to 4. Okay, so we'll start with k 4. Okay, so in this one we will eat all the bananas, so our value would be 0. Okay, it means that, let's take this ch. Ch means current r. Okay, so current r is 1 right now. She will move ahead to this element, then she will start again eating 4. If you have guessed that, okay, so we can simply do 6 divided by the value k, our current k. Okay, so that will give us, so not this, but we can take the seal value because we will not eat anything after that. Okay, so suppose for this case goes to 6, so we will get the value as, so we'll be taking the seal value. So 6 by 4, we will get 1 point something. Okay, so for taking the seal, we will just take the value as 2, right? So that way you will understand that. Okay, so this way we will take 2 value. Okay, I hope you understand that. So we will get the value as 2. Again, we'll move forward because we are done with it. Same thing, take the value for 7. 7 by 4 will give us the value as 1 point something. Okay, we will take the value 2 again. Okay, so we'll add 2 again, move forward. 11, you guess that the value would be 3. Okay, so our current value, current r is 8. So our current r less than equal to h. If that's the case, it means that this is the correct value. Okay, this k is the right value. So we will simply return the value. Okay. Okay. So this is the problem statement and a whiff of the intuition that I have given to you. Okay. So I hope you can find the brute force approach on your own. Okay. So if I'll give you the hint that, okay, so what we are doing, we are checking for from one value to the value until, suppose we can take what can be the maximum value if you think. Let's say, let's take an example. Whenever you can't decide, just take an example. Suppose we have this. Okay. In that case, the maximum value can be the maximum of these both, right? So the maximum bananas that it can eat, that can go as 100, right? Because there's no sense of eating 101 because we need the minimum one. Okay. Right. So this is for the maximum one. Okay. Now, you know that, okay, we'll start with one, then we will go to the max of our array, right? So this can be our for loop. We will iterate from the minimum position that would can be one. We'll check for each value until we found a condition that satisfies this condition. Okay. After that, we'll simply return the value as k, right? I hope this brute force approach is clear to you, right? So now we will jump on to our better approach. So now talking about the better approach, as you have guessed that, okay, we have given two things, right? So we have to find the minimum value, right? The first thing. And the second thing is we have given a range. So in the previous question, as you have seen that, okay, we have given what? We have given this range that, okay, from 1 to maximum value of array, we can get the answer. Okay. So we have to search the value of k, right? Listen to it again. We have to search the value of k such that we can get the value as minimum as possible. Okay. So does this type of question or this type of approach sound familiar to you? What about we talk about binary search again, right? I know this is a binary search series, so this question would be a binary search problem, but I know that you can now get the idea then how we can find if a question is of binary search or not. Okay. Now, with this information, we'll move ahead. Okay. So for binary search, what do we need? Couple of things, right? We'll simply use our binary search template, right? So in that, what we need, some condition, right? Condition, that condition would be according to the question. Okay. We have already found the range, right? Range means we found our left and right value. Okay. Now you know that we can find the middle value also because we have given these two equations. Okay. So this is same that we used to follow in physics and or maths that, okay, we have given this thing, we have given acceleration. So can we find that, okay, have we given any mass or we have given any force or something like that? Okay. So this is the same thing that we are arranging these things. So we have arranged that we have given the left and the range. So that way we get the values as left and right. So we can find the value of middle. Okay. After that, what we have to do, we have to check for the condition. So as you know, what we have to do, we have to traverse this array of piles. Okay. The bananas, this is the condition that we can use that, okay, for each index, we will iterate this array. Okay. And what we have to do, guess. So we have to do this thing, that is divide the current value with k and take the seal value of it. Okay. So the condition would be we have to iterate, okay, and our current r would increase if R real divisible by that P can be the index. Okay, I'll take as P divided by our value K. That K value we will get by mid. Okay, understood. So this is the condition part. Okay, now moving to the next part, that would be to move. So to move, what we have to do, we have to check the values are okay. If the value that we have taken for K or the middle value, if that's too much or too less, then we will move accordingly. It means suppose our mid value is somewhere around here, okay, at 2, right? Suppose we are at 2 mid value. Sorry, not 2, but our K value is, suppose the same example that we took, that suppose our K value is 2, okay? So if you will check it through our condition, I hope you can check it directly. So I'll be using it directly. Okay, so K is equals to 2. We will check that, okay, how many elements that we get from this one? 2, right? So it will take 2 hours. Plus for this one, 3 hours. This one, 4 hours, right? And this one, 6 hours. So our CH value would be, in this case, we will add all the things. That will give us 15. So this 15, so let's see. So this 15 is greater than the value of current H. Okay. So what we have to do? It means that this K value is very less. Okay. So we have to increase our K value, right? It means that we have to move forward. It means we have to move to the right. Okay. We have to move to the right. I hope you are getting the idea. Okay. Because we have to minimize this, right? To minimize this, we have, if this condition is satisfying, right? We have to minimize this. To minimize this, we have to move right. Okay. Because the range, if you remember, the range starts from 1 to maximum array. Okay. So our 15 value is very big, right? If we are taking this K value as 2, okay. So it means that, okay, we are satisfying this current R, but we have to minimize the value of K. Okay. Minimize this value of K. Sorry, not CH, but K. Okay. So we have to minimize the value of K. To minimize it, we have to move left. Sorry, right. Okay. We have to move right. I hope you understanding this question and this approach. Okay. Moving ahead. So to move our indexes, we have to take the same condition that, okay, if R's is less than current R, is less than equal to R H, it means that we have to move where? Left. Okay. Move left. We have to do what? We have to decrease our mid value. Okay. If that's not the case in the else part, we will simply increase the value. This is the same binary search template that we are using. Okay. So this is the condition that we are using. Okay. So if I summarize that, okay, if the current R is less than equal to H, it means that condition is satisfied, right? So we have to get the minimum value. So let's dry run this conditions into our this array. Okay. So our maximum value would be, now our left would be 1, our right would be maximum of this array. So the maximum would be 11. Okay. Our medium would be now 12 by 2. That would give us 6. Okay. So let's check for 6 when k is equals to 6. Let's check. The values would be 1. Okay. I hope you're understanding that. 1 again. That would give us 2. That will again give us 2. So our CH value would be 6. Right? Our H value is 8. Okay. So if it's satisfying the condition, it is satisfying the condition. So what we have to do, we have to move our left, sorry, right to this and left This, okay. So now we have to move our right to mid minus 1, okay, because our speed is too much, okay. So we have to minimize this value, the range, the k, okay, the search thing. So to minimize that, we have to move left in our range. To move left, we have to change the value of right, okay, vice versa. I know you have seen the previous videos, and you can follow along that, okay. So to move left, what we will do, we will simply change our value to mid minus 1. So right value would be mid minus 1, that would be 5. Okay, we have to find the value of mid again. So that would be 3. Okay, now check for 3. So our k value is 3 now. So let's check again. That would give us 1. That would give us 2. That would give us 3. That would give us 4. So the total would be 10. But that is greater than the value of h. Let's see. This is greater than. So if that's the case, we have to move our left pointer. It means that, okay, we have taken the k value very less because it is taking so much time to eat all the bananas. Okay. So moving ahead, we have to change the value of left. So left would give us now mid plus 1. So mid is 3. That would give us 4. Now we have to calculate the value again. Okay. So 4 plus 5 would give us 9. That would give us 4. Okay. Now the value is 4. Check again 1, 2, 2, and 3. Okay. Calculate the value again. That would give us. Okay. Now this is equal, right? So that way we are getting the values. Okay. This is equal. Now we will change our value of right. So our right would give us mid minus 1. So our right would be mid minus 1. So mid are 4 minus 1, that would give us 3. Okay. But our left value should always be less than equal to right. Okay. But in this case, our left value is greater than the right. So we will get out of the loop. Okay. So in that way, our value would be stored in the left pointer. Okay. So we will simply return the value of left. Okay. So this is the intuition for the binary search thing. Okay. So binary search pattern is now done. I hope you have understand this process also. So let's dive into the coding part. Start with the binary search. What we have to need two things. The first thing is the range. So the range will start from our left and the right would be, if you remember, the maximum of the array. Okay. Now we will calculate the value of mid. So to calculate the value of mid, you remember that, okay, we have to take the addition of both, right? After that, we will take our current R as 0. Okay. Now we will start our binary search. So our classic while loop would start from left is less than equal to right. Sorry, I have to put it in here. Now it looks good. Okay, now comes to the part of the condition, right? So the condition to iterate would be our for loop. So we will simply use our array, okay, and we will keep on increasing our current R value, right? And if you remember, we were taking the seal value, right? We were taking the seal value. We have to divide this current value by the value of k. So our k was our mid value. Okay. So our k was our mid value. Right. So moving ahead. After that, we have to move. So to move, what we have to do, we have to check that, okay, if we are moving left or right. Okay. So move is to left or right. We have to move. Okay. So if our R's or the current R's is less than or equal to our R's, then we have to increase our or change our right pointer because we have to move left. Okay. Else, what we have to do, we have to just simply change our right value. Okay. I hope this is the thing, and our answer would get stored in the value of left. Okay. So I think this is the code. So let's just try to run it and see if I have missed something. So this has submitted and it's pretty efficient. So I hope you have understood this question and also the solution and binary search template and other brute force approach also. So let's talk about the binary search time complexity. So the time it will take. So usually the binary search takes log n of time, right? But in the condition part, if you see, so we are traversing our array again. Okay. So for that case, we are iterating through the array. So that array, it can be n log n. Okay. Because we are iterating all the time to the array. So that n would be the length of the array. Okay. So this is the time complexity of it. So I hope you have understand this. I hope this question would be clear to you. So if you have any doubt or question, you can just simply drop that in the comment section. And that's it for the video. So I'll see you in the next one. Bye bye. Take care.